Hello friends, welcome back to our channel Mirror Neuron, which means watch and learn. Alright, so now we are going to discuss about the multivariate OLS loss function, which looks quite similar to the case where we have seen for the single dimension, where we had only one variable, and now we are dealing with multiple variables. So let's look into the loss function first. So the loss function L is given by the number of records we have and the summation for all the errors starting from 1, and this will be your original sales, in this case where we had the TV ads, the newspaper ad, whatever the original sale was, minus the predicted sales, right, and square of this one. Okay, so this can be written again as I is equal to 1, and this is nothing but your original. So we are trying to generalize, we are just taking one record at a time, and where I is the variable there. So this is the original value minus the predicted value. Okay, and this P or I all means the same thing. It just basically means the number of records. Okay, and this can be then rewritten as summation of I is equal to 1 to n, and this is nothing but here yi, the original value of sales, minus m0 minus m1 xi1 minus m2 xi2, and so on, and say we have till k features, so we will have mk xik whole square. Okay, so this is the expanded form. And now if we want to write it in the vector notation, and so this will look like as, so in vector form this will look like n times, the summation looks the same, but then this will be yi minus xi, this is a vector now, and this is a row vector. Remember, this is all the features value for that one record. So in our case it was like 230.1, 37.8 and 69.2, that record, right? And dot product with the coefficient. So this is in the vector notation. So these are just different ways of writing the same equation. Okay, and in L2 norm, so we have covered what is an L2 norm in our vectors and matrices classes. So if you want to revisit, but then we are not going to extensively use it, but you can just still do it for your revision. So in L2 norm, again this would be look like the y bar, which is a vector now of all the y values, minus the data matrix X, which means it has all the values of all the features, multiplied or dot product with m, and because this is a square and this is the L2 norm, so that's why we have a 2 in the superscript. And this can be then rewritten is, don't worry, it might look confusing, but then you don't have to go into too much of the details. It's just different ways of writing this equation in different forms, in vector, in expanded, or in L2 norm. And this same thing can be rewritten as y minus xm transpose times y minus xm. So this is basically because we are dealing with a matrix and a vector in an equation where we have, say, something like for a single variable, for example, say y is equal to mx square. This could have been written as y minus mx times y minus mx, right? So that way we didn't have to worry about the factors which you need for multiplying matrix and a vector. You remember, the dimension should match and all those things. So those things comes into picture when we have multiple variables. In single variable you could have just written it this way, because this is a multiple dimension variable, so that is why we have to use all this transpose and other thing. But generally what it means is we are just trying to separate out the factors when we have a square here. That's all. We are not trying to do anything fancy here. Okay, just because it's a matrix, that's why we have to make sure the dimension of this factor matches with the dimension of this factor, so that we can multiply it, and that is why we see all this fancy transpose and stuff. Okay,